10 million years ago, Earth was a paradise for apes. Towering forests blanketed much of the planet, and in those forests lived over 100 species of great apes, some as small as house cats, others towering giants like Gigantopithecus, weighing over 600 kilograms and moving through the undergrowth like living bulldozers. They were everywhere, climbing, swinging, roaring, thriving. It was a golden age, a time when apes dominated the animal kingdom. But today, that world is gone. The forests have thinned, the apes have fallen. Of that vast and once mighty family, only a handful remain. Gorillas, orangutans, chimpanzees, and us. But why us? Why this species of ape, fragile and tool-dependent, with soft skin and no natural armor, survived while the rest disappeared? What invisible thread of fate, chance, or adaptation kept our ancestors alive when the world around them was crumbling? Was it intelligence? Cooperation? Sheer luck? Or something far stranger? This is not just the story of extinction. It's the mystery of survival. A riddle written in fossils and DNA, stretching across millions of years. And to solve it, we have to go back to the moment when everything began to fall apart, and ask the one question no one can answer easily. Why didn't we go extinct? Chapter 1. The Planet of the Apes. Between 13 and 20 million years ago, during what paleontologists call the Miocene epoch, Earth was unrecognizable compared to the fragmented, deforested world we inhabit today. It was warmer, by several degrees globally, and more humid. Sea levels were higher. Ice caps were minimal or non-existent. And most significantly, vast stretches of the planet were wrapped in uninterrupted forest, from the equatorial tropics of Africa to the green hills of Europe and the jungles of Southeast Asia. These forests weren't just background scenery. They were ecosystems humming with life, home to some of the most fascinating evolutionary experiments the natural world has ever produced. And at the center of it all were the apes. Not the handful of species we know today, chimps, gorillas, orangutans, but over 100 distinct species, each adapted to their own environment, each following their own evolutionary trajectory. Some lived high in the canopy, leaping from tree to tree with acrobatic precision. Others roamed the forest floor in small groups, their behavior perhaps resembling modern gorillas or even baboons. Some were as tiny as domestic cats, while others, like the now extinct Gigantopithecus, were colossal, up to 3 meters tall and weighing more than 600 kilograms, towering over even the largest apes alive today. This era was not merely one of ape survival. It was a period of dominance, of exploration, of evolutionary experimentation on a planetary scale. The fossil record during this period bursts with diversity. In Europe alone, scientists have uncovered dozens of genera Dryopithecus, an arboreal brachiator, Pierolopithecus with a mixture of ancient and modern skeletal traits, and Uranopithecus, possibly a close cousin of the African great apes. In Africa, forms like Kenyapithecus walked with more terrestrial adaptations, perhaps venturing into newly forming woodland margins. Asia produced enigmatic species like Sivapithecus, with an eerily orangutan-like face, and Lufengpithecus, which may have shared traits with multiple great ape lineages. It wasn't just their anatomy that varied. Their diets, social structures, and locomotion strategies likely diverged as well. Some specialized in eating fruit. Others relied on tougher, fibrous plants. Some may have lived in complex, hierarchical groups, while others existed in more solitary arrangements. This explosion of forms and functions was fueled by a process called adaptive radiation, where organisms rapidly diversify when new ecological opportunities become available. And the Miocene was full of such opportunities. Continental drift had begun to reshape the planet's landmasses, connecting some regions while isolating others. Tectonic uplift altered rainfall patterns and carved out new landscapes. These slow but constant changes fractured habitats into environmental mosaics, different combinations of trees, terrain, predators, and food sources. In this ever-changing backdrop, apes did what successful lineages do. They adapted. They filled every available niche. Some swung through dense forests, others climbed cliff faces, swam across rivers, or foraged on the ground. Their bodies began to reflect their chosen survival strategies. Longer limbs for swinging, stronger jaws for chewing, curved fingers for gripping, broader pelves for balancing. Evolution shaped them like clay, sculpting solutions to problems that barely existed a generation before. And so for millions of years, apes weren't just surviving the Earth, they were mastering it. It was, in every meaningful sense, their planet. But as any evolutionary biologist will tell you, success is always temporary. Beneath the canopy of Miocene forests, invisible and slow-moving forces were already shifting the rules of the game. The Earth's climate, while still warm, was entering a long-term cooling phase. The polar regions began to freeze again, altering ocean currents and rainfall. Grasslands started to creep into the edges of the forest, replacing trees with open savannas. The continents, still drifting, continued to reshape ocean pathways and disrupt wind patterns. Forests began to shrink, fragment, and disappear in some regions. Apes that had been perfectly adapted to lush, stable environments suddenly found themselves in landscapes that no longer fit their needs. For the moment, they persisted. They migrated, clung to the remaining forests, or tried to adapt. But the stability of the Miocene, the condition that had allowed such extraordinary ape diversity, was slowly unraveling. Fossils from the late Miocene show signs of struggle. Shrinking ranges, fewer species, isolated populations. And yet, even as extinction shadows lengthened, one peculiar trend was beginning to emerge. Some apes were adapting differently. In particular, a few species in Africa began to show signs of bipedalism. Walking upright on two legs, an enormously inefficient way to move unless you're in open terrain. Why would an ape trade the speed and safety of tree life for the slow trudge across grasslands? And why, of all the dozens of Miocene ape species, would only this peculiar lineage, eventually known as hominins, survive the coming storm? These questions sit at the heart of one of the greatest evolutionary mysteries of all time. Because despite their brilliance, beauty, and sheer biological success, nearly all Miocene apes would eventually go extinct. Their once thriving populations vanished, their bones buried in sediment, their genetic lines snuffed out like candles in a storm. All but a few. A tiny, scattered handful of great apes survived into the present, and just one lineage, our own, rose to dominate the entire planet. Why? What did we do differently? What critical adaptations made the difference between extinction and expansion? The Miocene didn't just give rise to the apes, it also set the stage for their fall, and within that slow collapse, our story quietly began. To understand why we're here today, and why almost every other branch of our family tree is not, we must first understand what the Miocene apes were, what kind of world they lived in, and how their rise shaped the evolutionary crucible that eventually forged us. Because the most important question isn't just why they went extinct, it's why we didn't. Chapter 2. The Great Decline. The golden age of apes could not last forever. As Earth slowly transitioned from the lush embrace of the mid-Miocene warmth to the cooler, drier world of the late Miocene, the balance that had once allowed apes to flourish across continents began to unravel. This change was not sudden. It crept in subtly at first, almost imperceptible on a generational scale. But over thousands and then millions of years, it reshaped the very foundations of the ecosystems that apes depended on. Forests that had once stretched in endless, unbroken belts across Africa, Europe, and Asia began to retreat. Rainfall declined. Sea levels dropped. Grasslands started to encroach upon woodlands, transforming dense jungle into patchy, open savanna. For a species adapted to life in the trees, creatures that depended on fruits, leaves, and vertical mobility, this shift was catastrophic. The arboreal paradise that had birthed the ape explosion was disappearing, and with it, the habitats that supported their complex diets, social structures, and movement strategies. Apes, despite their intelligence and adaptability, were specialists, most of them fine-tuned to exploit very specific ecological conditions. And when those conditions changed, many were simply unable to keep up. One by one, ape species vanished. Their fossils drop out of the record like flickering stars snuffed out by darkness. In Europe, genera like Dryopithecus and Oranopithecus disappeared around the time forests were replaced by seasonal woodlands and grasslands. In Africa, species like Samburopithecus and Nacalopithecus, which had shown so much evolutionary potential, met similar fates as rainfall patterns shifted and plant diversity declined. Asia's towering Gigantopithecus, once the undisputed king of the subtropical jungle, clung on longer than most. But even this colossus could not escape the slow chokehold of environmental collapse. Its primary food source, likely a specific type of bamboo or soft fruit, became harder to find as the forests fragmented and died. Dentalware studies show that in its final days, Gigantopithecus individuals were suffering from nutritional stress. Trying to survive on fallback foods their bodies were never designed to process long-term. They were too big, too specialized, and too slow to adapt to the new world unfolding around them. But environmental change was only part of the story. What made this period so lethal wasn't just the loss of forest. It was the rising competition that came with it. As habitats shrank, ape species were pushed closer together. The broad territories they had once ruled were now reduced to narrow, isolated pockets. This forced different genera into closer proximity, competing for fewer and fewer resources. The principle of competitive exclusion, a harsh law of ecology stating that two species competing for the same niche cannot coexist indefinitely, came into play with full force. Some apes may have outcompeted others locally, but none could conquer the larger problem. Their entire biome was collapsing. And unlike the opportunistic monkeys, which diversified rapidly and could adapt to a variety of climates and food sources, most great apes were locked into the forest. Monkeys, with their faster reproduction, broader diets, and smaller body sizes, began to dominate the spaces apes were losing. Evolution, indifferent and relentless, had found new champions. Yet amid the collapse, something remarkable began to happen. Something so quiet and rare that it might have gone unnoticed had it not changed the future of life on Earth forever. In a few places, perhaps only small pockets of Central and Eastern Africa, certain apes began to behave differently. As forests gave way to more open landscapes, these primates didn't just cling to the trees, they stepped down from them. They began to move more often on two legs. They may have foraged in the scattered woodlands, ventured cautiously into grassy clearings, or walked along the edges of lakes and rivers, upright, hands-free. Fossils like Sahelanthropus chidensis, found in Chad, and Auroran tuganensis, discovered in Kenya, suggest that bipedalism, the act of walking upright, was already underway by around 6 to 7 million years ago. This adaptation may seem minor, but it was revolutionary. Standing on two legs changed everything. It allowed early hominins to spot predators over tall grass, to carry food or infants across long distances, to travel more efficiently under the blazing sun. It freed their hands for experimentation, perhaps with tools, throwing stones, digging roots, or shaping branches. It was not necessarily a conscious decision, nor a guaranteed advantage at the time. But in the long evolutionary game, it was a winning move. These first steps, awkward, uneven, and uncertain, marked the beginning of something utterly new, the birth of the hominin lineage. While most other ape species continued to depend on diminishing forests, the hominins began expanding their range into the very habitats that were wiping others out. They weren't the best climbers anymore. They weren't the fastest runners. They were vulnerable to predators. But they were generalists, capable of making do in patchy, unpredictable environments. That versatility, that fragile willingness to step into the unknown, would become the hallmark of our lineage. Still, the odds were long. The late Miocene was littered with failed experiments, branches of the ape family tree that evolved strange, specialized traits, only to vanish when those traits no longer served them. The fossil record is full of such ghosts. Powerful jaws now fossilized in stone, eye sockets staring eternally through time, limbs adapted for worlds that no longer exist. Some of these creatures were likely intelligent, social, even emotionally complex. But nature plays no favorites. Evolution does not reward brilliance or strength, only survival and reproduction. And as the late Miocene bled into the Pliocene, only a handful of great apes remained. The vast primate dynasty of the mid-Miocene was gone. What had once been a rich, branching tree was now reduced to a few stubborn twigs, clinging to life at the edge of change. And among them was the root of something strange and unprecedented. A lineage that would eventually stand tall, shape fire, craft language, and one day look back in awe at the time when the world was ruled by their cousins. The question was no longer whether apes could survive the future. It was whether the future still belonged to apes at all, and if so, which of them would carry that legacy forward. Chapter 3. The Rise of the Hominins. By the close of the Miocene epoch, Earth had become a world in transition, cooler, drier, and less forgiving. The once dominant apes had been pushed to the margins, their lush forest kingdoms transformed into vast stretches of grassland and scrub. Extinction had swept through their ranks, toppling species like Dryopithecus, Oreopithecus, and Sambaropithecus, leaving only a few great ape lineages to limp forward into the Pliocene. But in the shifting landscapes of East and Central Africa, something unprecedented was stirring. Amid the dying forests and rising savannas, a strange, awkward primate had begun to experiment with an entirely new way of living. It stood upright, not just occasionally like modern chimps or gorillas might, but habitually, even efficiently. This creature's spine curved to support vertical posture. Its pelvis had widened, its femurs angled inward to balance weight over the knees. Its feet, still grasping but less so, suggested that it was as comfortable walking across open terrain as it was climbing the occasional tree. It was not an ape in the traditional sense, but it wasn't human either. It was a bridge, a transitional being in the long story of evolution. These were the earliest hominins, and while they didn't know it, they were walking straight into the greatest evolutionary gamble of all time. The fossil evidence from this era is tantalizing but fragmentary, like scattered whispers from a forgotten world. Sahelanthropus chadensis, found in Chad and dating to around 7 million years ago, has a skull with a flat face and forward-set foramen magnum, hinting at upright posture. Auroran tugenensis, unearthed in Kenya, shows femurs suggesting bipedal locomotion, but with hands still adapted to climbing. Ardipithecus ramidus, dating to about 4.4 million years ago, has a bizarre combination of traits. A grasping big toe suited to life in the trees, but a pelvis that supports walking on 2 legs. These hominins weren't abandoning the trees entirely. They were straddling 2 worlds, surviving in a mosaic of woodland, grassland, and riverside environments where flexibility was more valuable than perfection. And this, perhaps more than any other trait, is what set them apart from the apes they had diverged from. Where their cousins had evolved to thrive in one specific environment, early hominins evolved to cope with many. Their bodies were not masterpieces of design. They were compromises, a patchwork of ancestral traits and emerging experiments. They were slower than 4-legged grazers, weaker than predators, less agile than monkeys. But they were learning to think differently, act flexibly, and work together. Bipedalism was just the beginning. Once their hands were freed from the job of walking, those hands began to change. They became more dexterous, more capable of gripping and manipulating objects. This didn't mean they were crafting tools yet, but the biological groundwork was being laid. With upright walking and versatile hands came new survival strategies, digging up tubers, carrying food or infants, maybe even wielding simple sticks or stones. These early hominins may have started cooperating in more complex ways, using vocalizations and gestures to share information about danger, food, or travel. Their brains were still small, but already evolution was investing in something different. Adaptability over specialization, social bonding over brute strength. Unlike the rigid ecological roles that had doomed so many Miocene apes, the hominins were emerging as generalists, creatures that could eat a wide range of foods, live in varied environments, and rely on each other for survival. And the environment they inhabited demanded nothing less. Africa was a continent in flux. Tectonic activity along the East African Rift was lifting the land and creating highlands, lakes, and valleys that disrupted weather patterns and produced dramatic shifts in local ecosystems. Some regions would cycle through woodland to grassland to semi-desert in just a few centuries. In such instability, only those who could move, adjust, and innovate would survive. The rise of hominins, then, wasn't a straightforward march toward superiority. It was a slow, stumbling adaptation to a world that kept changing the rules. Over time, these transitional species gave way to more derived forms. Around 3.5 to 4 million years ago, Australopithecus afarensis emerged, the species best known from the famous fossil Lucy. She and her kind walked upright more efficiently than their predecessors, though they still climbed trees when needed. Their dental anatomy suggests a varied diet, including fruits, leaves, seeds, and possibly meat. They were clever problem solvers, though still far from the cognitive sophistication of modern humans. Yet their footprints literally mark a turning point. At Litoli in Tanzania, fossilized tracks dating to 3.6 million years ago show 2 or more individuals walking upright across volcanic ash, side by side. These impressions are more than just physical traces. They are historical imprints of a new kind of primate, one that was beginning to walk into the future. Meanwhile, other branches of the hominin tree also emerged, like Australopithecus africanus, Australopithecus anamensis, and eventually the robust but short-lived Paranthropus genus, known for its powerful jaws and plant-based diet. Each was an experiment. Some adapted for chewing tough vegetation, others for more generalized foraging. Some lived in relatively stable habitats, others pushed further into unpredictable environments. And then, around 2.5 million years ago, another shift occurred. A new genus appeared, Homo, and with it came a suite of traits that would radically redefine what it meant to be a hominin. These early Homo species, such as Homo habilis, had larger brains, smaller teeth, and more human-like body proportions. They were beginning to make stone tools, the first confirmed instance of technology in our lineage. With tools came new opportunities: butchering meat, cracking open bones, digging deeper, surviving longer. This was the dawn of culture. Rudimentary, perhaps, but profound in its implications. These hominins weren't just reacting to their environment, they were beginning to reshape it. The rise of the hominins, then, was not a tale of triumph, but of tenacity. They were not the dominant species of their time. They lived among predators, competed with scavengers, and struggled against the same environmental upheavals that had doomed their cousins. But they possessed one key trait that tipped the balance in their favor: adaptability. Their survival wasn't guaranteed. It was earned day by day through cooperation, experimentation, and constant compromise. In an evolutionary landscape littered with extinction, they were not the strongest or the fastest, but they were the ones who could change. And in a world that no longer rewarded specialization, that made all the difference. From these uncertain origins, a lineage would emerge that would cross deserts, build fires, bury its dead, carve tools, and eventually look back across millions of years and ask, how did it all begin? It began here, in the shadows of extinction, with a strange bipedal ape learning to stand against the wind. Chapter 4: Homo erectus and the Mastery of Adaptability. By the time Homo erectus emerged around 2 million years ago, something extraordinary had happened. Evolution had taken a previously scattered, vulnerable group of bipedal apes and shaped them into a new kind of creature. A traveler, a firemaker, a builder of tools, a true ecological generalist. Homo erectus was not merely another hominin species, it was a turning point, a creature so radically different in behavior, anatomy, and reach that it effectively redefined what it meant to be human. With longer legs, shorter arms, narrower hips, and a more modern gait, Homo erectus could walk and run across vast distances, covering open savannas and woodlands with a speed and efficiency no hominin before it could match. Fossils of Homo erectus have been found across an astonishing range. From East Africa to Georgia, China, and even Indonesia, making it the first human species to truly leave Africa and spread across continents. But what allowed it to do this wasn't just its limbs or lungs. It was its mind. With a brain size significantly larger than its predecessors, averaging around 900 to 1100 cubic centimeters, Homo erectus had crossed a crucial cognitive threshold. This wasn't intelligence in the modern sense, but it was enough to coordinate hunts, learn new skills, remember distant locations, and most importantly, adapt to unfamiliar environments. They made tools with purpose and planning, shaping stone into hand axes and scrapers using the Acheulean technique, which remained virtually unchanged for nearly 1 million years. That kind of technological stability speaks not of stagnation, but of efficiency. These tools worked, and they worked everywhere. With them, Homo erectus could butcher meat, process plants, and defend itself from predators. And perhaps most transformative of all, there is evidence to suggest that they could control fire. While the exact timing is debated, hearths and charred bones at sites like Zhoukoudian in China hint at a revolutionary leap, the ability to harness flame. Fire changed everything. It extended the day. It provided warmth in cold climates. It deterred predators. It allowed the cooking of food, making calories more accessible and reducing the energy cost of digestion. This in turn may have fueled further brain growth, creating a feedback loop of advancement. But fire also had another, subtler consequence. It became a social anchor. People had to gather around it. Stories, rituals, plans, whatever nascent culture existed, began there, in the flickering light of shared flame. And culture, even in its earliest form, is a multiplier of survival. It allows knowledge to pass not just from parent to child, but from group to group, generation to generation. With culture, innovations don't die with their inventors. They spread and accumulate. This, more than any single trait, gave Homo erectus a staggering advantage over the natural world. Unlike most animals, who could only evolve biologically over thousands of years, Homo erectus could adapt behaviorally within a single lifetime. That meant survival was no longer limited by biology alone. It was augmented by learning, cooperation, and memory. This species didn't merely exist within environments. It conquered them. And it did so during a time of great geological and climatic instability. The Pleistocene epoch, which began around 2.6 million years ago, was marked by repeated glacial cycles, ice ages that radically altered global climates, sea levels, and ecosystems. These shifts were brutal. In Africa, dry spells turned forests into deserts. In Europe and Asia, glaciers advanced and retreated, burying vast regions under ice. Most species could only survive by staying in the same biome and hoping it wouldn't disappear. But Homo erectus had no such limitation. When the land changed, they moved. When food became scarce, they changed what they ate. When predators threatened them, they learned new strategies. This was the first truly adaptive hominin, capable of surviving not because it was best at one thing, but because it was good enough at everything. And this generalism, combined with endurance, is what made them unstoppable. Consider this. Homo erectus lived for nearly 1.5 million years, longer than any other hominin species in history. That's over 7,000 human generations. They outlasted their ancestors and siblings. They witnessed the rise and fall of river systems, the shifting of entire ecosystems, the appearance and disappearance of other megafauna. They endured droughts, floods, volcanic eruptions, and ice ages. Fossils in places like Dmanisi, Georgia, show they were already outside Africa by 1.8 million years ago, adapting to temperate climates, new prey, new terrain. In Java, Indonesia, they may have survived as recently as 100,000 years ago, sharing the planet for a time with Homo sapiens. Their global spread, long lifespan, and cultural resilience make Homo erectus one of the most successful species in the entire human family tree. And yet, they were not immortal. Even the most adaptable creature must eventually face its limits. Around 500,000 years ago, newer human species began to emerge. Homo heidelbergensis in Africa and Europe, Denisovans in Asia, and eventually Homo neanderthalensis and Homo sapiens. These successors had larger brains, more refined tools, complex language, and deeper symbolic thinking. Compared to them, Homo erectus was slower, simpler, and less socially sophisticated. Over time, They were outcompeted, marginalized, and eventually replaced. But their legacy was profound. They were the pioneers, the pathbreakers, the ones who proved that it was possible to live beyond the forest, beyond the familiar. They crossed deserts, climbed mountains, followed rivers into the unknown. They were not a dead end. They were a launch pad. Without Homo erectus, there would be no us. Their fire, their tools, their courage, these were the raw materials from which our species would be shaped. And perhaps the most important thing they passed on was not a specific gene or tool, but a mindset. The ability to survive through flexibility, to learn, to move, to adapt. In a world that punished specialization with extinction, Homo erectus proved that generalists could not only survive, they could thrive. And in doing so, they laid the foundation for the most improbable evolutionary outcome of all. A species that would one day look back and ask, where did we come from? The answer begins here, with a clever, persistent, fire-wielding ape that refused to stay in one place, and by doing so, lit the path for everything that followed. Chapter 5. The Last Survivors. By the time Homo sapiens emerged around 300,000 years ago, the story of the apes had already become a tale of attrition, a long, slow whittling down of an evolutionary dynasty that once ruled entire continents. The great ape family, once boasting over 100 distinct species during the Miocene, had been reduced to a mere handful, scattered across shrinking patches of forest or clinging to ecological margins. Extinction had come for nearly everyone. Even Homo erectus, the globe-trotting, fire-making pioneer of the human story, had begun to fade. In some places it lingered, Java, for example, but elsewhere its lineage was eclipsed by newer, more cognitively advanced hominins. And as the climate swung between glacial and interglacial extremes, Earth became a harsher place to live. Species that could not adapt quickly enough were pushed toward extinction, not by meteor strikes or massive volcanic eruptions, but by a quieter, more insidious killer: relentless environmental instability. Into this high-stakes arena stepped Homo sapiens, not as a triumphant conqueror, but as just one more experimental branch on a family tree littered with failure. We were not alone. At least 6 or 7 other human species still walked the earth. Neanderthals in Europe and the Middle East, Denisovans in Asia, Homo heidelbergensis, Homo naledi, Homo luzonensis, Homo floresiensis, and perhaps even the last remnants of Homo erectus. And for thousands of years, these species coexisted, interbred, competed, and adapted. In caves and on savannas, in highlands and river valleys, our ancestors shared the world with others who looked strikingly like us, different in detail, but human in form and behavior. So why are we the only ones left? Why did we, and no one else, survive the crucible of extinction? The answer lies not in one singular trait, but in a constellation of advantages that compounded over time. First, our brains were not only large, but uniquely efficient. The structure of Homo sapiens' brain allowed for complex language, symbolic thought, and mental time travel, the ability to imagine things that weren't immediately present, like tomorrow's hunt, a rival's intentions, or the layout of a distant valley. This cognitive leap enabled the birth of culture, not just tool-making, which many hominins had mastered, but the accumulation of knowledge across generations. We developed not just tools, but instructions for making tools, not just stories, but myths, not just warnings, but strategies. And this meant that every innovation, every sharpened stone, every woven net, every carved spear could be passed on, improved upon, and remembered. Unlike other species who had to adapt genetically over millennia, Homo sapiens could adapt behaviorally in a single lifetime. Second, we were hypersocial. Larger, more interconnected social networks allowed ideas and innovations to spread rapidly between groups. These hybridizations suggest not only genetic exchange, but perhaps social and cultural interaction as well. The Neanderthals, once painted as brutish and dim-witted, are now recognized as intelligent, capable toolmakers who buried their dead, wore ornaments, and may have even painted on cave walls. But their populations were smaller, more isolated, and more vulnerable to environmental disruption. Genetic studies show they had lower fertility, higher inbreeding, and possibly slower rates of innovation. In a rapidly changing world, even small disadvantages compound. And so, one by one, the other human species vanished. Not in a single moment, but over tens of thousands of years, through climate shifts, competition, interbreeding, and perhaps even disease. By around 40,000 years ago, only one hominin species remained. Us. Homo sapiens, the last survivors. But our survival came with a weight. We inherited not only the world, but the ghosts of all who came before us. The Miocene apes who once dominated the treetops, the early hominins who took their first uncertain steps upright, the firemakers and tool carvers, the Neanderthals who shared our genes and landscapes. Their stories live on in bones, in DNA, and in the very shape of our hands and faces. We are not separate from them. We are them, refined by time, chance, and adaptation. And yet, in a strange twist of fate, the same traits that ensured our survival now place us at a crossroads. Our intelligence, our mobility, our ability to alter the environment. These gifts, once our salvation, have become the source of new existential threats. Habitat destruction, climate change, nuclear weapons, global pandemics. The last surviving hominin may now be the first species with the power to cause its own extinction, or to prevent it. In the ruins of the Pleistocene, after millions of years of evolutionary trial and error, Homo sapiens stands alone. Not because we were the chosen or the best, but because we were the most adaptable. The final inheritors of a fallen dynasty. The last of the apes who learned not just to survive, but to remember.